We're going to talk about exponential growth and decay. So I kind of wrote this on purpose here. Growth is when we have a situation that's increasing or growing. Decay is when we have a situation that is getting smaller, decreasing, descending, decaying, depreciating, all of those kinds of words. So we have two formulas that we use for growth and decay. So first up, we have y equals p1 plus r to the t. And then we have y equals p1 minus r to the t. And then just to make sure, let me make that look more like a 1, so you know we're talking about a number there. So I hope that this will make sense. We have talked before about knowing if something increases or decreases in size. So if you think back to when we were working with parabolas, we knew by looking at the a value whether our parabola was going to be normal size or stretched, or if we had a parabola that shrunk. And it was all based on that value of a. So let's just talk for just a second, refresh your memory, that when we have an equal to 1, nothing changes. So nothing changes. All right, if we multiply by something bigger than 1, we're going to grow or increase. And if we multiply by something less than 1, it's going to, in this case, decay or decrease. So last unit, we would have called this a stretch if our a value was larger than 1, and we would call it a shrink if our a value was less than 1. So this is just talking about what happens when we multiply by ... All right, so thinking of that, hopefully you will look at this and it makes sense that this on the left is the equation for growth, because we're going to end up multiplying by something bigger than 1. And this equation is the one for decay, because we're going to end up multiplying by something less than 1. So this one is the growth equation on this side, and this equation is the one for decay. All right, so now what I want to do is go through what each variable represents. All right, so first up, the y. The y is talking about the current value or the balance. Most of the time, that's what you're being asked for. All right, the p is the initial or starting amount. So if you buy a car, it would be the cost of the car. If you are putting money in the bank, it's going to be how much money you start with. So that's the initial starting amount. It's known as principal, which is why it uses the letter P. The R is the percentage rate. And the only real comment here is that we will change this to a decimal. And if you think about it, when we type into a calculator, we'll use decimal form rather than percent. And then the T is talking about the time. And usually that will be in years, not always. If we have something happening, every hour, or something happens so many times per year, whatever it is. But a lot of times this is going to be the amount of time in years. All right, so what's going to happen is we're going to look at a situation. We're going to decide whether it's a growth or decay. We're going to look for these values, fill them into the equation, and grab a calculator and work it out. So here we go with example number 1. I'm going to slide this up here. So let's say for example 1, you buy a car for, let's say your car is $21,000. The value is depreciating by, let's say, 6% each year. So find your car's value in 5 years. All right, so you buy a car for $21,000. The value is depreciating by 6% each year. Find your car's value in 5 years. So first thing we want to do is identify whether it's a growth or decay. And this right here tells us that the value is depreciating, so we know that this one is going to be a decay. So depreciating would indicate that it is losing value. All right, so we know we're going to use the decay formula, so let's go through and identify what each thing stands for. 21,000. That's going to be your starting amount. That's the P, the principal amount of the car. 6%, that is going to be your rate, but remember we're going to change that into a decimal, so 6% would be 0.06 as a decimal. And then we have 5, and that's going to be the time. So what we're going to do is go back to the decay equation, and we're just going to fill it in. So y is the current value. So we're looking for the car's value in 5 years. So we're looking for y. All right, the initial or starting amount was $21,000. It is decaying, so we have 1 minus the r, which is 0.06. And we want to find the value of the car in 5 years, so the t is 5. So at this point, we're going to grab our calculator. Let's see if we can get this to show up so you can follow along. And I am going to type exactly how it's written. So we have 21,000 parentheses 1 minus 0.06, close the parentheses, exponent 5, and then hit enter. And this gives me the car's value in 5 years. So $15,411.98. So remember, money is always 2 decimal places. So the value in 5 years, $15,411.98. So that's your answer. All right, let's try another one. And I think for space, I need to go on to the next page. So example 2, move on over here. Okay, example 2. Let's say that the cost of college tuition, in 2000 was, let's say, $7,500. There is a rise of, let's say, 9% each year. So what is the cost of tuition today? All right, the cost of college tuition in 2000 was $7,500. There's a rise of 9% each year. So what is the cost of tuition today? So first thing we want to decide is if this is a growth or decay. So hopefully you notice that the price is rising. So this is going to be a growth. All right. And now let's go through and identify what each variable is going to represent. So the 7,500 is the principal amount. That was the original amount. The 9% is the R. Remember, we write that as a decimal, so 9% as a decimal would be 0.09. Now it says the cost today, but this 2,000, we are going to use this 2,000 and the fact that we're being asked for today to determine that the value of t is going to be 20, because this year is the year 2020. So in 2000, it was this amount. Now, 20 years later, that means our t is 20. All right, so we're going to fill in the equation. So we're using the growth equation. So y equals the starting amount, 1 plus 0.09, and the exponent of 20. So now you grab your calculator, clear that out. So we have 7,500, parentheses, 1 plus 0.09, close the parentheses, exponent 20, and we get the cost now is $42,033.08. So the current cost of tuition is $42,033.08. All right, so for our last few examples, what I want to do is just make sure that you can look and understand what an equation is telling you. So for example 3, let's say you had y equals 18, 0.92, we'll just leave t. All right, so if we had this equation, I have no idea what this might represent, and I asked you a few items. One of the things that I might ask is, what is the starting or the initial amount? So the initial amount is that value of p, which in this equation is 18. All right. Let's say I was looking for whether this was a growth or decay. So if it is a growth or a decay, now to figure that out, we're going to look right in here. And since this number is less than 1, 0.92 is less than 1, we know that this is a decay. All right. Now, let's say I asked you what is the rate of decay. All right, the rate of decay. Well, if this is 0.92, that right there is 1 minus r. So if 1 minus r is equal to 0.92, then how much has decayed away? So if you think about it, this is 92%. If you got a grade of 92%, that means you lost 8%. So our rate of decay would be 8%. So I knew that this one was a decay because it was less than 1. And since it was less than 1, I knew something had to have been subtracted from the 1. So that will give you your rate of decay. I hope that covers it. If you need to rewatch, please do. And yeah, I think that covers it, and good luck.